Greetings and welcome to another edition of Aviation Safety Risk Management through Hazard Analysis. This video is dedicated to risk mitigation. So let's jump into it. In the previous videos, we started off looking at risk frameworks, and the example used there was an icy intersection of two highways. And so we're revisiting that. And at the end of that presentation, I introduced the risk matrix. The second video dove deeper into the risk matrix. And so here's an example of where we are at the end of the first two videos. We've got the risk framework on the left, and that is populating the risk matrix on the right. One thing to note if you saw the risk matrix video is I mentioned that a traditional way of expressing risk through a risk matrix is to plot one point in a risk matrix. You can see that using the combination of a risk framework with a risk matrix allows you to plot the probability of outcomes at all 5 of these levels of severity. It's still not perfect, but it's a much better technique than only plotting one point in a risk matrix. So with that, and this being our baseline, let's move on and see what we can do about mitigating this risk. The first thing that we want to try to do, if it's feasible, is to attack the hazard. If we can reduce the probability of the hazard, generally speaking, that's plan A for us. So what I'm going to do, since we're talking about a hazard of ice on these highways, I'm going to propose that we introduce salt or maybe some other chemical to try to melt the ice and convert that icy road into a wet road where the traction will be a little bit better. And what we'll do is we will reduce the number of cars that are exposed to an icy road or the hazard of an icy road. I've just done that mathematically. And as an example, as sort of a round number, we started with 25 times per year is how often the roads ice up. And just to demonstrate the technique, let's say that these ice trucks or the salt trucks will reduce that number to 10 times per year. So that'd be 100 days over the course of a 10-year period, which is the horizon we're looking at with this risk framework. So if we're able to do that, we can now take another look at our risk matrix to see how this kind of a mitigation shows up in a risk matrix and how we can communicate this change in risk graphically. This is what it looks like. So now instead of seeing one set of dots in a matrix, we've got two different symbols that are in two different places. The blue dots with the black center are what we call the current risk or maybe the historic risk. That's where we started. And what we've done is we've reduced the probability of outcomes at all levels of severity by mitigating the hazard. Think of it as we've lowered all of the positions of those points in the matrix. Notice in the risk framework itself, though, by putting salt on the roads, we didn't change any of the other conditional probabilities in the risk matrix. So the conditional probability of an accident and all of those probabilities associated with the outcome have remained unchanged at this point. The total risk is coming down because of that change we made to the hazard probability. Our next technique for mitigating risk is to go after the accident. And one thing we might do is we might require the use of tire chains when the roads are icy. I grew up in Maine and this was a real thing. There were times when you had to have tire chains on your car if you wanted to go down certain roads. So the object here is to improve the traction of the vehicle, but you can see that tire chains don't do anything to change the weather. So they're not going to do anything to change the probability of the hazard occurring. Instead, what we're hoping to do here is to change that conditional probability of an accident occurring given that the hazard does occur. So this is the number we're going after right there. And if you think back to the previous slide, you saw that it was 40, and now we'll just say again, to use round numbers, that we've reduced 25% of those and brought it down to 30. Again, neither of the probabilities on either side of that one are changing. We're specifically targeting that middle number in this case. Here's what the risk matrix looks like, and there's not a lot of difference between this one and the last one because this change is relatively subtle compared to the first one. But those gray triangles, turns out they have black diamonds underneath them. They're moving just slightly lower than they were in the last matrix. Our third mitigation technique is to try to target the severity distribution, those probabilities under the outcome column in our risk framework. As you know, a seatbelt doesn't do anything to change the weather, and seatbelts don't prevent accidents. But what they can do is, in the event of an accident, they can change the outcome to something less serious. And that's what the seatbelts are going to do in this particular case. What you'll notice when I update the risk framework, you'll see that that 7% number is going to change, and the number of fatal injuries that we expect over time will be reduced. But one of the really important concepts is the law of total probability, which says that under that outcome column, all of those conditional probabilities, when added together, have to equal 100%. So if the percentage of fatal injuries goes down, that probability has to go somewhere, and some other number somewhere else is going to have to go up, or potentially a combination of things will have to go up, but at the end, they have to add up to 100%. So there's the update, and you can see that those numbers have changed. The probability of a fatal injury given an accident has been reduced from 7% down to 3%, and that probability has been essentially redistributed to some of the lower severity events. So just speaking plain English, we've prevented the fatal injury and we've made it a less serious outcome. So possibly a critical injury, maybe a minor injury, or maybe we prevent the injury altogether or the damage. Here's what the corresponding risk matrix looks like now that we've applied these risk mitigation techniques. The thing to notice here is the contrast between the change on the far right and on the far left. Notice that the blue dots are still in the same place they've always been, but we've progressively reduced the risk of the fatal accident through those different mitigation techniques, starting with the blue dot, moving to the black diamond, and then ultimately ending up where that gray triangle is at the bottom. But on the left side, you see a different relationship. Again, we started at the blue dot. Initially, by mitigating the hazard and the accident probability, we reduced the risk to where that black diamond is. But then when we redistributed the probabilities under the outcome column, we wound up pushing that gray triangle back up. And this is what we are trying to do. This is what mitigation is all about. And that increase under the severity 5, no injury, no damage, increasing that outcome is the same as reducing risk. Another way of thinking about this is we're trying to push the risk from the right to the left when we are trying to mitigate the severity distribution. And that's ultimately what you're seeing. Some of those accidents that used to be fatal are now probably critical. Some of the criticals became serious. Some of the serious became minor. Some of the minor became none. And of course, it could play out so that some of those things change across more than one category, but in general, that's what's going on here. And that's the goal of trying to mitigate a severity distribution. Anyway, I hope that information is helpful to you and gives you a little better idea of what risk mitigation is all about. As always, if you'd like to get in touch, provide any feedback or comments, my email address is right there. Also, you're certainly free to leave likes or comments or subscribe, all that kind of stuff for YouTube. See you on the next one.